I want to quickly talk about how to use the tcdf. So to find the tcdf, you go to second vars and then you look for tcdf. So second vars and then you look for a tcdf, which is right here. And then so let's do an actual example. So let's say I want to find the probability that t, again I gave you the t that is after standardization. T is less than, let's say, a 0.75, and then n is equals to 20. How's that? So we have a curve. I know the t curve is determined by the sample size or the degree of freedom, but when you draw a t curve, just draw a bell curve. We have mean is equals to 0 right in the middle, 0.75, and then this is the area that I am looking for. So to get the area, this is equal to tcdf, and then the left limit is negative infinity, and then to 0.75. The right limit, do we need the right limit? The right limit is 0.75. What is next? The next thing is you have the degree of freedom, which is 20 minus 1. All right. So we have negative infinity. How do you type the negative infinity? So very slow. You type -1. Again, negative is the key between the decimal point and enter -1. And then second, type the comma, because there is a double E on the upper left hand corner of comma, and then 99, comma 0.75, and then you can be very lazy because you are using technologies, 20 minus 1, and then you close the parenthesis, or you can type 19 if you want to. So the t is equal to 0.769, because I like to use 3 decimal places for the t, and then 4 decimal places for probability. Oh, we are doing probability, sorry. So the probability, this is not a t anymore, I was talking too fast. So the probability is equals to 0.67688, 88, 4 digits for probability. We will do the inverse norm after we finish this. Let's do one more. So this time I want to do a right side. So t is greater than 0.16 in negative. So we draw a curve, 0, negative 0.16, and then a greater than, and then I have to give you an n, of course. So let's say n equals to 7. So what's the probability equal to? So that is a tcdf from negative 0.16 to positive infinity, and then the degree of freedom is 7 minus 1. So let me specify that this is the degree of freedom, and then you do this in your calculator, right? So second vars, do something wrong, second vars tcdf, and then negative 0.16, not minus, don't use the minus key, and then comma positive infinity 1, second comma 99, degree of freedom is 7 minus 1. So we have a probability 0.5609. So that is my probability. What if I have an area in the middle? So let's say I want to do t between how about negative 0.5 to positive 1.7, and then we have this 0, so that is negative 0.5, that is positive 1.7, and then we try to get the area. So that is a tcdf from negative 0.5 to 1.7, and then n, I need a degree of freedom, so you need to give me a sample size. When you do t, you need a sample size, because the sample size gives you the degree of freedom. The graph is determined by the degree of freedom. The shape is determined by degree of freedom. So let's say this is 11, then you have a 11 minus 1 for the degree of freedom. So we go to second vars tcdf, and then negative 0.5 1.7, and then 11 minus 1. Let's try 10 this time. I do the math by myself. So this is 0.6261. So that is how you do tcdf. So the next thing is I want to do inverse t. Let's change color for that. Inverse t. So let's say I have this 0 right in the middle. I want to cut some area on the left. So let's say I cut right here. This is my area, and that is 28%. I want to find the cut. I told you how much I got. I told you how big the cut is. You have to tell me where to cut. In the green problem, the tcdf problem, I told you where to cut. You have to tell me how much you cut out. All right? So this t is inverse t, and then you have to input the area, 28, and then degree of freedom. And let me give you a sample size. So let's say a sample size is 28. Then this will be a 28 minus 1. That is my degree of freedom. So we go to second vars, inverse t, and then 0.28. The degree of freedom is 28 minus 1. So we have negative 0.590. Do I need to remove the negative? Nope, because t is on the left hand side of 0. So let's do one on the right hand side. Oh, how about this? I got a good one for you. I make a cut right here. I want this area. The area is 65%. This is a 0. This is a t. So inverse t, if you are still looking for inverse t, let me tell you, if you are using a TI 83, the 83 plus, there is no inverse t. You have to program the inverse t by yourself. All right? I will tell you how to program the inverse t in a separate video, because I haven't done that for a long time because all of my calculator has an inverse t in it. So we go to second vars, and then we do inverse t. I like to write it out. Inverse t, 65%, and then what is my n? Let's say n is equals to 52. Then this is a 52 minus 1. So 0.65, 52 minus 1. Then you have 0.387. Let's keep 3 digits for the t. Is this correct? Almost. What's the problem? The problem is you have a t on the left hand side. Although you pick the right area, right side area, but the right side is too big, so that step across the middle, and then now you are on the left hand side. So any t on the left hand side of 0 is negative. So you miss a negative right here. This is negative 0.387. What if you have an area right in the middle? So let's say we have 60%. How's that? 60% right in the middle. And then this is a 0. How do you find a T1 and a T2? This is the area that I have. First, you have to find the area on the left side and on the right side. You have 60 in the middle, right? So if you take 100% minus 60 equals to 40 divided by 2, you have 20% on each side. Let's do one of them. So the T1 is inverse T, and then you have 0.20. The degree of freedom, you have to give me a sample size. So let's say the sample size is 66. Then this is a 66 minus 1. So let's find out what T1 equals to. So second vars, we have inverse T, 0.20, and then a 66 minus 1. You have negative 0.847. So that is my T1 is on the left side of 0. Of course, we use negative. and then T2 is positive 0.847. So that's how you find the inverse T if you have a piece of area right in the middle. Okay, so that will be all in this part. I will see you in the next part.